Start recording. Share my screen. Share. Okay, I think we got it now. I think we're on a roll. All right, in the natural selection assignment, the very first question is related to peppered moths from 1959 all the way to 1995. And what you see here is there's a scenario that kind of explains out those peppered moths. We see the population in 1959 having many more dark colored moths. And then as we go from 1959 to 1979, we see a decrease in the overall percentage of dark colored peppered moths. Notice that there are 10 of the little peppered moths here, which might represent 10% of the population for each one. So in this case, we've got 90% are black or darker colored pepper moths and 10% are light colored moths. And then by the time we get to 1979, we end up with about 20% of them being light colored moths and the other 80% being dark colored moths. But then we make our way all the way to 1995, and that's very different. We end up with almost the complete opposite, 20% being dark colored and 80% being light colored. And so what it's wanting you to do for this is it's wanting you to compare our fit fishes lab. That's what it's talking about for the paradigm lab. Compare our fit fishes lab to this scenario in this 3-box storyboard. So I want you to write a verbal representation of the events depicted in this storyboard, and then address any elements that maybe come out in our fit fishes lab as well. For B, it wants to know, do you think natural selection is occurring over this time period? So from 1959 to 1995 during that time period, do you think natural selection is taking place? And then justify your answer. And then how would that scenario have changed if there weren't any predators in the environment? So in this scenario, read what it talks about as far as predators in here, and then would this scenario have played out the same if there were not any predators in the environment? And then the next portion here is comparing our fit fishes lab, similarities between the fit fishes lab, and differences between the fit fishes lab comparative to the peppered moth activity here. Okay. D wants you to consider air quality and how it may have changed in 1995. What distribution of moths would you expect to now see in 25 years or 75 years based on if that water quality that air quality may or may not have changed. So it was talking about England having continued to maintain the quality of air up to 1995. What types of things would we think that we would see with the peppered moth population 25 years after 1995, 75 years after 1995, and then justify your answer there. The number 2 is talking about a Rudyard Kipling story, a short story about the elephant's child, and it's talking about long trunks versus short trunks, and it's wanting to know in this scenario, what's going to happen with this population of elephants if a crocodile reaches up, grabs a hold of the trunk of one of the short trunked elephants, stretches it out. Now we've got one in the population that has a long trunk and all of the rest have short trunks. What do you think might happen each generation? In order to do this, you're going to have to use the insert, drawing, and new button because it's asking you to actually draw out what you think this 3-box storyboard is going to look like, and maybe refer up here to this 3-box storyboard. But it's wanting to know what's going to happen over time. So you're going to have to actually create a drawing here. So I've already created a drawing. What I did was I copied this picture and then I went up to insert, drawing, and new. And so you should be able to paste in that picture. So it looks a little something like this. And here, once it loads, then you can use these little icon, the little tools up here as far as entering pictures, and maybe you want to like add a shape. And so I've grabbed old here, and for whatever reason, it's taking forever. Maybe I didn't click on it the first time. There we go. Now I got it. And so maybe I want the shape to be pretty much the same. So now I've got that elephant trunk that kind of matches that. So I've got my long one, and then I can do a short one, and I can just copy and paste them into the boxes. So consider what it's asking in there. Consider that a crocodile stretches out the elephant's trunk, and now we've got one in the population with a stretched out trunk. Maybe that matters, maybe it doesn't, but maybe do a little comparison between our Fit Fishes lab. And then write a verbal representation of the storyboard that you create. Like, what do you think is going to happen, and why do you think it's going to happen? B wants you to think back to all the scenarios that we explored or discussed during our Fit Fishes lab. Did any of them remind you of this scenario? Was there an example where we're saying, oh, that's kind of like this from the Fit Fishes lab? If there was no similar scenario, come up with a modification to the lab to simulate the scenario that we have there. C is asking you any key concepts that the scenario illustrates that may have been left out of our understanding of evolution by natural selection currently. One of the examples that I gave one of your peers earlier was this idea of behaviors. We haven't really talked about how behaviors might play into the characteristics that certain groups of organisms exhibit. And so the question is, are behaviors in the cards, or are behaviors that are they something that are completely different? So when we were doing Fit Fishes, we were exchanging cards, and those determine the characteristics that we have. But ultimately, we need to know our behaviors part of that as well. So kind of think about that there. Number 3, the American chestnut tree is a tree that's found in the Appalachian region. And in the early 1900s, the chestnut blight, which was a fungus that caused chestnut trees to die. Actually, this spread throughout the United States. It wasn't just in the Appalachian area. And eventually it really caused a negative effect on the American chestnut trees. And it was accidentally introduced to the region by the Chinese chestnut tree. So maybe think a little bit about our Fit Fishes lab, and think about some of the scenarios that played out when we had an invasive species that was actually accidentally entered into our environment, and what effects it had on the Fit Fishes. Same thing here. It's asking you to do a drawing, a 3-box storyboard drawing. So again, you're going to copy this picture. You're going to go up to insert. You're going to go drawing and new, and you're going to draw out, paste this picture, and then draw out what you think is going to happen in 1 generation and then 10 generations later. The next one, so that's what it was asking there. Complete the storyboard. What do you think might happen to the population over time? Explain and justify your storyboard in the space below. So basically just saying, hey, this is what I think is going to happen, and this is why I think it's going to happen. And then what scenario from the lab, if any, does this scenario remind you of? If it does not, come up with a modification to the lab that might simulate this type of scenario. And wink, wink, nudge, nudge. Maybe the invasive species portion is a hint at this. And then question number 4, I think, is our last question. So what this question wants you to do is it wants you to look at this cliff swallow population, and the distribution of body sizes over time. And what we notice is that the population shifts. And so it might not be immediately apparent to you in this graph, but basically what this graph is showing is that we have this bell-shaped curve. And the majority of the population in 1976 falls about halfway between high and low as far as their body size. So they got like medium size as the majority of the birds in 1976. There's a few of them that are quite a bit smaller, and there's a few of them that are quite a bit larger, but the majority of the population falls right in this area. By 1978, that whole population has shifted towards the larger size. So you can see here where the average population size is not somewhere in the middle anymore. It's shifted towards the body weight being a little bit higher. And so what it's wanting you to do then is it's wanting you to storyboard this process between 1976 and 1978. You could add little pictures here. If I was to click on this, and it looks like maybe we even got a 3rd box in here, maybe that's just missing. Nope, we just got 2 boxes. So I'm going to click on it and go Control C. I'm going to go up here to insert drawing and new. and I'm going to paste that picture. Maybe I'm going to paste that picture. It doesn't seem to want to pop up for some reason. There we go. All right, so now I've got my 2-box storyboards in this case, and maybe I want to like pull up a picture of these swallows. And so I can go into the image button and I can go search and I can type in, I don't know, swallow. And I like to put no background in there so then I don't have a bunch of blocky background. And you might even include like swallow clip art as an option. Oh, but hey, look at, we got some swallows. So we have all kinds of choices here. Maybe I want to use this one. And so here in a second, it's going to pop up a swallow. Here I've got my little swallow in the population. And so I've got that one. And maybe I want to show the population similar to what it says earlier, where I want to see that the population is, each one represents 10% of the population. Or maybe I could do 5 of them and I could say, well, each one represents 20% of the population. So I've got my little swallows there, right? And I could copy and paste a whole bunch of them. And then over time, we noticed a change in the swallows. So maybe I'm going to go Control C, and then I'm going to paste another swallow, and I'm going to drag it over here. And maybe I want to make the body size larger on this swallow. So maybe I'm like, okay, oh, there we go. I've made the body size a little bit larger and my swallow's a little bit bigger now to show that change in the population over time. And maybe you're really interested in this bell-shaped curve or this graph that's happening. So maybe you're saying, well, I got a couple of them in there that are really kind of small. And then I've got a bunch of them that are kind of medium. So I do a bunch of different size changes to them. And then over here, maybe I change those sizes a little bit to show that even though there are some small ones, there's not as many small ones in the population. And even though there might be some large ones, there's not as many super large ones in the population. So here's a really big one. And then maybe most of them in the population are medium sized. So I put in a whole bunch of medium sized ones just to show that the population is mostly medium sized. All right. I'll click save on this. It's going to take and put all those swallows in there. So it's just wanting you to then finish the 3-box storyboard here and then provide a verbal description of the process of natural selection shown in the graphs. Like what could be driving this population change that's happening from kind of a medium-sized average bird to a larger average sized bird by 1978. All right. Good.
Okay. Yeah.
Okay. All right. I'm going to stop sharing then. And I'm